So I'm going to create a new file, and we'll just call this stats.py. So let's use NumPy first. NumPy is very, very popular for just mainly for manipulating data, mainly just numbers. Okay, that's why it's called numbers, like numeric Python. The library, you can, I believe, it comes by default already with Python, so you don't have to do any installation. If it's not there, you can just do the pip install again, pip install or conda install NumPy, right? But it should already be there. If it's not there, you can check it by going to the command over here and just try to import it. So if you go here, if you import NumPy, and if there's no error, then you should have it. If it's not there, then I mean I don't have NumPy. Okay, so I don't have it there. So for example, if I do import PyMongo, right? You see there's no error. Okay, so that means I don't have NumPy installed. I mean, I have to install NumPy for my machine. And the other one is the Matplot library. So you can try that too. So import mat. Just just T. It's not math, but just Matplotlib library. And I don't have that either, right? So I don't. Do you have it in your machine?
I have it.
Good. Yeah, I don't have it. Weird. So let's see. Why don't I have them? Did I not? Because I remember I didn't see that in my command over here. That's not good. Yeah, I don't see matplot here. So I'm going to install it, see if it works. So I'm going to go again, conda install NumPy. You can install all together one time, I think, NumPy and then the Matplotlib. And let's see if it will let me install. Just say yes to continue. So it's going to install the latest version. And if you know the exact version you want to install, you could put a version number next to it. And let's see, NumPy, okay. That's why I don't have it.
Why don't you have it?
I don't know why. Okay, so done, right? It's pretty quick. And just make sure it's in there, pipe list. So here is, so I don't have Panda either, so you can install that. So this map, okay, good. And NumPy. Okay, so I'm good here, so I can close this now. And then I can try it again. That's good to go. And then NumPy is also good to go. Are we good? All right. So over here then, I'm going to go into the command here and import. You can import both of them, NumPy. And I don't want to type NumPy every time, so you can make that shortcut to just say NP. It's very common. That's a shortcut. And then I'm going to import also the Matplotlib as sometimes they just call it PLT for plot. I'm going to plot it. So we'll see what so you can basically use those and then just use the shortcut. It's better that way. So again, The Matplotlib is just for visualization. Numpy it's a huge library that you use for data storage and calculations and so forth. It mainly contains structures and a lot of functions, and it handles a multiple or multi-dimensional arrays. It's very common in that, so they call it the ND array. It's another very common function in NumPy called ND array. So that will give you a very flexible way of creating arrays in n dimensions, and you can easily swap, change back and forth just by issuing one simple command. You see there. Now Python also has an array library which we never talked about. So let's just say if I go here and import array, this is a Python base. So array in Python, which we usually don't use it, we use list instead, right? Because list is like an array. But the array library in Python is usually, again, only works for numbers. It stores only numbers. You can probably store strings and others too, but it's mostly common for numbers only, and it's usually only one dimension. You don't have the ability to create multiple dimensions in an array. So NumPy, takes a step further from the array library, and it allows you to create multiple dimensions. Again, deals with numbers only. So in Python, usually you have like, for example, if you say data, you would say like this can be an array of array, and then here you put a list of arrays. So the first is a type code, it's a Unicode, and all the data type you can use from like integer to signed integer to Unicode to float to double and all those stuff here. So typically you use the I here for integer type, and then comma, and then use a list of numbers in here. So like 1, 3, 5, 7, right? So that is an array of numbers of 4 elements inside the array called data. And we never really use this, but because we use list instead. Okay. So it's not really useful in this scenario. So again, this array library, the type array is so confusing, so people usually go as AR or just A, and then you replace that with this AR here, right? Just an object. So if I say this and I run it, and you see that over here, it doesn't show in the Explorer because it's an object, but if I type in data, you see that it's an array of integer I, and has 4 elements. And you access it the same way you do with a list. Like the data of 0 will give you the number 1, the first element, and so on. Okay, and you can replace it just exactly like in a regular list, except this way it's all numbers. So that's array in Python. Now the NumPy extends that, so now you can create multiple dimensions. So here I cannot create 2 dimensions. Like for example, here is 1 dimension. If I want to create 2 dimensions, I would do you remember how to do that? Right? Put a comma, and then here another group here, 3, 4, 5, 6, and then you will wrap both of those inside that. So that's a 2-dimensional array, right? You can see here, if I save it, run it, so it doesn't allow you to create multiple dimensions in the Python array library. So that doesn't work. So what you can do is now in NumPy, no problem with NumPy. In NumPy, you can create an array very easily like this. You can say again data equals MP, that's the shortcut, right, the alias, dot array. I can do that as well. I don't have to include the integer I here. I can just copy this and put it into the array here, right? And let's see if I save that and run it. So far so good. If I type in data, so here's a two-dimensional array. So it's much nicer than. And now, since we have the array here, let's watch and see what we can do with this array here. Okay, I created over here. It's much faster. We just do it in the console here. Okay, now the data, it tells you it's an array. If I type in type of data, that it's a NumPy in the array, right? Not a Python array like before, because we created with the NumPy library. Because it's a NumPy library, and the NumPy has a lot of very, very powerful, useful functions. And if you want to know what they are, I showed you earlier that you can do the dir, and then you type in the data. It's a part of NumPy. Put data here. It will tell you a list of probably a lot of them, functions and attributes you can use. You can find the minimum, the max in there. The item. A lot. Okay, we're not going to explore all of them, but one of these you see here is probably two very interesting ones. It's called the reshape, the shape, and something called the ndim, the n dimension. Those are very popular.
And what did you type in that list?
Just the dir, and then you put in the data variable in there. You can type in NumPy too, I think. That will not, I guess, not the library, but the actual object. So again, data has those two dimensions, and if you want to know how many dimensions it is, you can just say data dot ndim. It tells you it's a two-dimension array, right? So NumPy will give you that very, very easily. And it has number of elements. You can say, again, data.size. It tells you have 8 elements in there. And now, the shape, data.shape, it tells you that it's a 2x4 array, right? 2 rows and 4 columns. Now, what if you wanted to rearrange that? I have 8 elements. I could do a 4x2 instead, right? So you can swap that around. You can say I want to have my new data is equal to data.reshape. I'm going to pass it now. I'm going to change the shape. Instead of 2x4, I want to have 4x2 instead. So you hit that enter, and then I change my data, because if you just call it itself like this, it doesn't make any changes to the actual data. You have to assign it, right? So now if I show my data, it's a 4x2 instead of 2x4. It rearranges automatically for you, right? And then if you go to ndim, you see that now it's a two-dimensional still, but if you go to the shape, it's a 4x2 instead of 2x4. Pretty cool, huh? As long as you know the number of elements, and if you know that they will match up. So I have 8 elements. So 4 times 2 is 8. 2 times 4 is 8. I can go 1, 8, 8, 1. Or I can do 2 by 2 by 2, right? So you could say data equals data.reshape 2 by 2 by 2. Because I have a total of 8. As long as those numbers work, then you can reshape your data. And now if you look at it, it's a 3-dimensional array now. So it's 2 rows, 2 columns, and 2 layers deep. Okay? And if you type in data.ndim, you see that it's a 3-dimensional, not a 2-dimensional anymore. So you can go back and forth very easily using NumPy. Imagine you have to do that manually or do that in your code. as you loop through the whole array, decide, when to pause, when to stop, and then redo it. It does it automatically behind the scene because, still, it does go through that for you. But the library does it already, so you don't have to do it, which is pretty cool. And so that's the ND array for NumPy. So I showed you here, we created initially using the array function, because I created this way. And because I do it this way because my numbers are unique, right? Well, I can choose my numbers. If you don't care about the numbers, if you just want to set any number from a certain range to a certain range, you can do it separately. You do it differently. So let me go back here and turn this off, and let's create another data equals to np dot, this time not array, but a range of array range. So a range. Okay, it's called array range, a range. And then now, this one works very similar to the range function we did earlier. So I can say from a range from a certain number to, let's just say, 20. Okay, let's save that. And let me clear my console over here, and I'll run it. So it's in memory now. If I type in data, you see that it creates a number from 0 to 19 at 20 elements as a single array. Because if I type in data.shape, it's a one-dimensional array. 20 comma nothing is a one-dimensional array. And then I have 20 numbers to play with. So I say, hey, cool. So the data equals the data dot reshape this to a 10 by 10. Well, that's no, 10 by 2, right? Or 5 by 4. As long as you multiply them, you get the correct number, 20. Then that'll work. So now I have a table of 5 columns, 5 rows and 4 columns. Started from 0 to 19. And then you can do what I did earlier. You can resize it, change it to a 3-dimension. You can make 4 dimensions out of this if you want, right? 20 numbers, like what? 2 by 2 by 2. Okay, I don't know. Yeah, by whatever it is. And so you make it fit. You can make n dimensions. That's called ND array. Okay, so this one starts from 0 to 20, like the range. I can say, well, you know what? I don't want to start from 0. I want to start from maybe 4 to 20. So 4, this is the starting, and this is the ending. Not inclusive, if I'm not mistaken. So if I run it again, now my data has been renewed, and now I have from 4 to 19, not inclusive in the last one. So I'm starting with 4 instead of from 0. And then I want to reshape it again. So so after that, if you want to do it, so you can do something like, I got that, and then in your code you would do like data equals data dot reshape, and it's how many numbers is that? Like 16. So maybe 4 by 4, right? So if I save that and run it. So my data now it's a 4 by 4. Before that I did it manually in the console, but you could do that in here as well. And if you look at this, I mean, Python does allow, what is that term called? Method chaining. You can chain methods in Python as well, like you do in JavaScript. because this is data, so therefore I can do something like that, right? I create my array from 4 to 20, then I want to reshape it to 4 by 4. Or if you want, it would be like, 2 by 5, and then 2, right? That's a 3-dimensional array. You can shape it any way you want, as long as these numbers multiply up to be that total of. No, that's too many. I had 20. Can't be it. So 2 by 4 by 4. No, but 2, right? 2 by 4 by 2. 16 numbers. So 60 numbers, and then you run that. Now you have data is equal to, it's a 3-dimension, 2 rows, 4 columns, and then 2 deep. Okay, so you can see the method chaining here. You can use that for a shortcut. And not only that, you can see that I could start from 4 to 20, and then is it 4, 5, 6, 7, 8, 9, 10? You can skip those two. You can say I want to start just only. You increment by 2 instead of by 1. So by default, it is 1, right? The step is 1. So 4, 5, 6, 7, 8. Now I'm going to say 4, 6, 8, 10, all the way to 19. And if you put 21 here, so that I have. So this number doesn't match anymore because I have to count how many I have here. So let's just say we remove that reshaping and just run that. So I'm starting from 4 to 20, but I want to do an increment of 2. So then my data looks like that's a 2, 4, 6. So 4, 6, 8, 10, 12, 18, and 20. So pretty cool. Very, very, very quickly you can generate numbers. You can also do the reverse. It has to be, the order has to make sense. If you put a -2 here, I'm going the other direction, then I'm not going to get anything because, it's already false, right? Yes, you want to put the large number first from 20, so from 20, starting that to 4, if you want to include 4, it has to be 3. And then you go in the reverse order from 20 down to 4. 3 when I include it. If you run it now, you see that I have my number in the opposite direction. So going down from 20 to 4 instead of the other way around. So exactly same as we did with the range. And now because it's an array, you can print them out. Like the array, and we did in the code. So here we could do right here in the command prompt. So my data has that many elements. If you want to print it out using a for loop, you can go something like for the index I, right? For I in the data. So find the data, and then colon, enter, and then you can say print the data of I. Okay, and it's going to print those numbers for you in order from 20 all the way down to 4. And if you want to, also maybe we'll put a and is equal to just a space. Hit enter twice. Oops. Out of range, index 20. Did it wrong. Oh yeah, that's incorrect. That's incorrect. Let's see again. Data. My syntax. It's not correct. It's not data. It will be in the range of the length of data, right? Or you can say data.size. Data.size. No, it is the length.
Yeah.
Len, right?
Yeah.
Len data. Yeah. And then so you'll print 0 to 20. I had it correct. You can use the range, or if you're going to print the actual data, you could just go here. You press up arrow, show the command, and then use the actual data right away. And then you just print not data but I, right? We did this before. Because I now has the actual number already. So this way you can print every single value from the actual data without using the index. So, and again, that's just regular printing, looping through the data because it's an iterable data type. And there's a lot more. If you want to learn more about it, you can go to the site. I think there's a numpy.com or .org site. If you go there, it shows you tons of information as well you can learn from. But as you can see, it's very easy for you to manipulate data, right? Change data to reshape any size you want. So when you test data, that's when you plot or print out information. You need something that really can do this really quickly for you, and that's why NumPy is used for that purpose. Very fast. So you can see how we can create using the array function or using the range function this way, the aRange function, to generate data in the array space. And then you can reshape it however you want it. Okay. I think that's all I wanted to cover about that one there. And you can see what else can do here. Okay. Reshape them. Yeah, you can move, remove, and you can pop those data too, just like the array, like on the list, right? So, for example, back in the data here, I have those numbers. I can like pop the first element. Oh, doesn't have it, or maybe not pop them. Maybe remove. Let's see. Data remove number 20. Really? Doesn't have it there? I thought he does. Let's see. Maybe it doesn't have it. No, it doesn't have it. I was thinking about the Python array maybe. Yeah, you can remove it.
How do you remove them? There's no pop there?
No, there's no pop. There's no. Yeah, you can copy. Well, the copy is just make a copy of that array. This is a deep copy versus a shallow copy. It has those terms because it's an object, right? So, for example, data is that. If I put a equal data, and the a has the same copy, if I change a's data, it's going to change d2, right? If you make a copy, then you want to use that a equal to data dot copy, and then that will copy to the a as a separate array, so they are completely separate. You just have the actual data, but now you cannot change the so you're not sharing the memory locations. So okay, so that's good enough for the NumPy. And then let's go over to the matplot here. And I'll leave this as is for now. And so the matplot is you can plot straight lines, linear lines, scatter. You can plot pie charts, graph, bar charts, and all sorts of stuff in there. So let's just say I'm going to go and create a. So in order to create a chart, you need coordinates, right? The x and y axis. Okay. So to do that, you would do something like, let's just say that I have the x has the numbers 1, let's do very simple, 1, 2, 3, 4, 5. Okay, it's a 5 numbers. And the y is equal to, only thing is when you do this, the x and y has to match in that size. So I could do maybe like 3, 6, and then 2, and then 10, and then 5. So my x-axis and y-axis. And then now I can plot it by doing something like PLT. We use PLT here. So let's see, PLT dot. As you can see, I have. Let's see. Yeah, when I do a date. Okay, let's see. Let's see if I remember this right. PLT dot plot x and y. Okay, let me clear my console over here. And let's see. Okay, I probably did something wrong here. Is it a pipe plot or Matplotlib as PLT? Oh, I think you have to download it. Not the library itself. There's a pipe plot here. Pipe plot. Yeah, I'm missing that one. As for the mat library, I want the pipe plot, and that's the one that is going to plot for you. It's PLT. Okay, so now let's try again. Let's see that. Did it work?
Yeah.
Yeah. Right. Yeah. So there it is.
I did not ever do that test assignment. I saw it in the book when it was to do it. I didn't know it was going to actually use the console.
Yeah. So it plot that for you. As you can see, the x-axis is from 1 to 5. So you can see that it's kind of tiny, but it goes from 1 to 5, and then the y-axis is 3 to. It will automatically resize for you. The smallest number is 2, and then the largest is 10. So between that, you have your actual numbers, right? The 2 here, 6, 2, 10, and then 5. Okay. This is a plot using line, right? So if you want to change it to another one, so down here you can plot it again, PLT, not plot, but you can use a bar chart instead, X, Y. Okay, you run it, you should see 2 charts being printed. One is on the same chart, of course, PLT, but one is a bar chart, one is the plot. And you can do more to get in the same chart here. So it's kind of hard to see here, but let's just say that I'm gonna use the just the bar chart. Okay, so you can comment this out and run it again. So this is the chart here. So you have a kind of nice bar
Easier than I expected.
Yeah, very easy, right? And you can add like the label as well. We didn't add the label for the x and y axis. You can say plt dot x label, and you put a name in there. So let's see, like let's just say this is the I don't know, maybe like time, for example, and then the y label will be the maybe height or something, right? Whatever it is. And then if you replot it, it will have that label added for you right down here, time and label. And if you want the label of this chart, what this is about, you can add it to your bar. I didn't have here but an x and y. You can add here label as a third parameter equals, you can say, I don't know, bunny jump, I guess. Whatever it is, over time. And that will give you a label. That didn't show up here. Did I do it wrong? There's a way you can put a label for this chart as well. I might have it incorrectly. Well, yeah, anyway, so one more thing that we take a break. So instead of bar, because bar is kind of hard to say, if you go back to the plot, and let's say if I copy this again and make another one, like maybe I call it x2 y2 and the same number, or yeah, the same time but different numbers. I can do like that, and 26, and then we 1, and then a 1.2, and then maybe a 3. Okay, so when you plot it, I plot that one there, and I'll plot it again. Okay, I'm not sure the label is not working. I probably had it wrong. But x2, y2, I'm plotting it. So you see the line plot. And so you can print two on the same graph and compare them for those five attempts. So this is a default color based on, I guess Python shows that for you. And if you want to change the color, you can change it to a different color too. So I think you just maybe add it here. Let's see, color is equal to red. The first one is red. The second, maybe I want it to be pink. Let's see if that's part of it. So yeah, well, kind of. I can choose different colors and things like that. And then if you choose back to plot, and if you want to change to a different thing, you say scatter instead. And now you have different graph stats now. And if you want to connect those dots by either like a dotted line or dash or whatever it is, you can do all those stuff too. So. Okay, we'll take a break.